Okay, this week we are going to be talking about the second part of metabolism, which really concerns activity and exercise. We're going to be talking about what happens to our muscle tissue as the levels of activity changes, meaning when we go from being really non-active to as we progress to high levels of exercise. When we're at rest, the oxidation of our muscle uses the combination of glucose and fatty acid, and that is sufficient for our muscle because there is a low demand of oxygen. So the two basically get the energy out of glucose and fatty acids. We need to utilize oxygen as well. So there are two phenomena that we deal with when we are utilizing energy. Is first the fuel, which is glucose and fatty acids, and also amino acids, but that's just another scenario. We're going to be focused on glucose and fatty acids, but then also the fact that we need to have enough oxygen available at the onset of activity. So meaning that it's just starting, the very first few seconds, the muscle is going to deal with the storage of the ATP that we have, and that suffices the muscles. Okay, so when you're just starting, just the very first few seconds, but the ATP that you work so hard for, you know, when you consume all that meal and you store the ATP, as we have been talking about in the last few chapters, it only suffices muscle activity for the first few seconds. After that, our first energy system starts working. So we have three energy systems that helps the muscle create energy. The first energy system that starts working after the depletion of ATP that the muscle has stored is called, and it has to, the muscle uses it because it needs the ATP quickly. It is the energy that the muscle gets from the phosphate. Phosphate bonds are very enriched in energy, all right? So that's why we get ADP plus phosphate, we get ATP, okay? So muscle fiber concentration of the phosphocreatine is 4 to 5 times greater than the ATP that it has stored, all right? And that is the energy system that we have, the phosphocreatine that the muscle has. But it only is 4 to 5 times higher than what it already has stored as ATP. So the first energy system that goes into effect, it only lasts the muscles 15 to 25 seconds longer. So the first system, as I was telling you guys, will last the muscle the first few seconds. The second system, okay, I'm not going to call this first one a system because it confuses you. The first situation that the muscle has lasts the muscle the storage the first few seconds. Then the first energy system that goes into effect lasts the muscle up to 25 seconds. After that, system 2 goes into effect. So what is system 2? System 2 is your lactic acid system that most of us are very familiar with because that is what causes us fatigue. You know lactic acid system because of the pain that it causes you through exercise, during your exercise. So it's a glycolytic pathway. Why is it a glycolytic pathway? Because if you remember from glycolysis, how do we get lactic acid? When glycolysis goes through completion, when it happens, it gives us 2 molecules of pyruvate when glycolysis happens under aerobic condition, all right? However, when it's anaerobic, when we do not have enough oxygen, then glycolysis, the completion of glycolysis gives us lactic acid, okay? So when so many things are happening so fast to our muscle cells, all right, and which is really the onset of activity and system 2, as I like to call it, we do not really have enough oxygen, and that is why the anaerobic situation happens, and it happens to all of us, okay? This system also happens as the fight or flight response. So you know, when you see something so scary, like when I see a cockroach, for instance, my goodness, I still do not understand the whole point of cockroaches on this universe. They're absolutely so scary. So when I see them and I just run for my life, nothing can make me run for my life faster, honestly. But the reason I can run so fast is system 2. Alright, it makes me run so fast. It's not my fitness level at all. It's because we have that, and this is an evolutionary adaptation that we have made. All of you have it. All of us have it, whether you get scared or whatever. The fact that you're able to continue your activity after the first 25 seconds is because of the lactic acid system, or system 2. The glucose source that this system uses is your muscle glycogen. It is not dependent on the glucose that you have running through your bloodstream, which is an absolutely fantastic adaptation. So when your body is using this system, it is not depleting your blood glucose level, so you won't faint. Not really, you won't faint when this system is taking place. But it is using the glycogen that you have stored in your muscles. Also, this is a very important system in swimmers. Alright, very important system in swimmers, because they need to start an activity, they need to increase their activity level to a faster speed really quickly, and that is why it's an important system. That's why I have put a photo of a swimmer here, so you guys will make the association. So the advantage of this system is that it can generate ATP very quickly for high intensity exercises. Again, swimmers. The lactate that is produced by this system rapidly crosses the muscle, and it goes to bloodstream, and then it goes to liver, where in the liver can produce the aerobic ATP, and aerobic ATP is high intensity ATP that we can utilize, and all that good stuff. All right, so this ATP is it's very important for us. This lactate that is produced is very important for us, because it can cross the muscle cell into blood and then into liver really fast. That's why this system is very important. At the onset of this system, obviously the lactic acid concentration is low, so you don't feel much. But as the exercise is going on, so most of us do not stop our activity after the first, 50 seconds, right, or 40 seconds. The lactic acid concentration now is building up. It's building up. Lactic acid, the name is on it. It's an acid. So since it's an acid, it's bringing down the pH of your blood. When the pH of the blood is coming down, really what it means is that the H concentration, the H ion concentration in your blood is going up. When the H goes up, what is it that you feel? Fatigue, especially if you're not trained, which we will talk about later. So that is why you feel the pain. The pain that comes upon you is because of the acidic condition of your blood. But it is your powerhouse for about 20 to 75 seconds before all of this happens, and your body goes to this system. It does not avoid this system and just jump up to system 3. Your body goes system 1, then system 2, then system 3. Okay, so the sprinters that run 800 meters, or the swimmers that swim up to 200 meters, they massively use this system. It's a very important system, and it's an absolutely fast system. Remember that. So whatever athlete that uses a very fast, rapid, that needs a very rapid situation, they use this system massively. Now system 3, that goes through the entire cycle. Remember Krebs cycle, at the end of it, we have the whole electron chain, and that's where we get the actual energy. All right, so if your exercise is lasting longer, that is when the whole Krebs cycle happens, and that's when the system 3 comes into effect, and that's what we call the oxidative system. Why? Because it goes through the entire thing. It goes through the completion of Krebs cycle. The main source of the fuel here is fatty acid, and that's why here your fitness matters. the level of fitness of somebody for this system to really work matters. Since the oxygen that is necessary, the oxygen that is necessary for this system, it's called the oxidative system. So the amount of oxygen that your body can utilize here really matters. And here, the amount of oxygen that you can really have your body utilize, it depends on your level of cardiovascular fitness. So both your fitness, physical fitness, and your cardiovascular fitness matters. So how do we measure that? How do we know if somebody is actually fit in terms of oxygenation, really? We call that a VO2 max value, that I'm sure loads of you have heard of it. So VO2 max is defined as at a point at which a further increase in the intensity of the exercise no longer results in an increase in the volume of oxygen uptake. Okay? Now, VO2 max is really, in putting it in a simpler way, is how much oxygen you can uptake to burn your fuels with. So the higher oxygen you can utilize, the more energy you can get from the fuels you're consuming. This value can change as you get more physically fit. All right. It depends on a number of factors. There are contributing factors to it, but just a normal, not a normal, I shouldn't say normal person, but a person that does not exercise a lot has a lot lower VO2 max level. Maybe 20 to 30% is the VO2 max level. But people that do cross-country skiing, they have the highest VO2 max value. It goes up to 90% because they are the ones that really they utilize loads of oxygen. And that is not to say all the other athletes are not as fit. It's just because of the type of the exercise, because they use system 3 a lot more than other athletes. So now the factors that contribute to VO2 max is the ability of the blood to deliver oxygen, glucose and fatty acids to the exercising muscle. It's your pulmonary ventilation. So if somebody is a smoker, or they just, for whatever reason, or somebody has asthma, they do not have the optimum pulmonary ventilation. Oxygenation of hemoglobin also, altitude definitely does play a factor here, and release of the oxygen also from the hemoglobin at the muscle. These are all the contributing factor to the VO2 max. But I just want you guys to know that this value can change as your level of fitness changes.